everybody, let's quickly get the answers to these quiz questions. Here is the first one. A 5 kilogram box is sliding 3 meters across the floor before coming to rest. And what is the coefficient of kinetic friction between the floor and the box if the box had an initial speed of 3 meters per second? The plan in this problem is to know that the kinetic energy of the box has been wasted in trying to do work against friction. So we know the formula for kinetic energy, we know the formula for work, which is force of friction multiplied by distance, so we can take it from there. And here is how we do it. So kinetic energy is equal to the work against friction. And all you have to do is plug in the given numbers, calculate friction first, and then once you get friction, you know that the coefficient of friction is the force of friction by the normal reaction. And the normal reaction here is mg because it's on a flat surface. So that's number one. And here is the airplane question. The airplane flies 120 kilometers at a constant altitude and it's flying in a direction 30 degrees north of east. A wind is blowing. The direction of the wind is not given, but we know that the net force, horizontal force on the plane is 2.40 kilonewtons in a direction 10 degrees south of west. So the plane is flying 30 degrees north of east, but the net force is acting 10 degrees south of west. From those two, we should be able to figure out in what direction the wind is blowing. All right, so this is how we go about it. So this is the direction in which the airplane is flying. That's 120 kilometers. And you can see that this is the net force acting at an angle of 10 degrees, which is south of west. And we know that work done is FD cosine theta. In this case, we have the net force, which is 2.4 kilonewtons, but we do not have the displacement in the direction of the force. So we have the displacement here, and we have this net force. So when you take d cosine theta, we're going to get the displacement in the direction of the force. And from the problem, we know that this angle is going to be 20 degrees. Look at the diagram, and that should be very clear. This is 30, and this net is 10, so this must be 20. So when you take d cosine 20, you get 112.76 kilometers, and then use that to multiply it with the force to get the work done. Now, I've also done it another way here for those who would like to see it this way. You see that this total angle is 160 degrees. 160 degrees. So when you do FD cosine theta, you're going to get negative, because cosine 160 is going to be negative something, and therefore you will get negative so many joules. Now the negative shows that it's doing work against the wind, so that must be very clear. I hope you understood this. And here's number 3. And the scalar product of a vector 3i plus 2j and a vector b is 12. So the scalar product is 12. Which of the following vectors could be the vector b? Now since it's a multiple choice question, it's easy to do this. Because when you take the scalar product, you can write a dot b is equal to 12, and then take it from there. A is given as 3i plus 2g, dot b is equal to 12. And b is a vector, so it should be like xi plus yj, where we're looking for x and y. So in the next step, that's what I've done. Replace the vector with xi plus yj, And then when you take the dot product, you take the product of the coefficients of I, which gives us 3x plus 2y should be equal to 12. And now you got to choose from the answers because there's only one set that will work. And that's going to be 3 times 6 plus 2 times negative 3 is equal to 12. So now we know that the vector is 6i minus 3j, because none of the other combinations will give a scalar product of 12. So that's done. Brings us to number 4, and here we are asked to find the work done from the position or the force position graph. To find the work done from the force position graph, you just have to find the area. So when you find the area, you divide it into two triangles, as you can see, and a rectangle, and find the areas. The area of the triangle is 1/2 times base times height, plus the area of this rectangle is 2 times 10, because this is 2, and then you have 10. And then similarly, the area of this triangle is 1/2 times the base is 6, and the altitude is 10. So when you do that, you get 70 joules. So that's one more done. Here's the next one, which is quite simple. A spring with a spring constant of 2500 Newton per meter is stretched 4 centimeters. Remember, that's in centimeters. What's the work required to stretch the spring? Of course, the work required is 1/2 kx squared. K is 2500. X is 0.04. Put that, square that, and you get 2 joules. Let's move. Here's the next one. How much energy is needed to change the speed of a 1600 kilogram vehicle from 15 meter per second to 40 meter per second? This is the work-energy theorem. The work done is equal to change in kinetic energy. That's all. Work done is equal to change in kinetic energy. So what you got to do is find the initial kinetic energy and the final kinetic energy. Find the difference between them. That'll be the work done. So there it is. I've just taken 1/2 mass outside. So that's actually the difference in kinetic energy, and you get big numbers. So that's 1.10 megajoules. Mega is 10 to the power 6 joules. Here is the next question. A ball is thrown upward with a speed and direction such that it reaches a maximum height of 18 meters above the point it was released. And at that height, it has a speed of 20 meters per second. With what speed was the ball released? This is a clear case of conservation of energy, because at the bottom where it was thrown from, it only has kinetic energy, because we take the ground at the point where it was thrown from. And so the total kinetic energy that it had at the bottom should be equal to the potential plus the kinetic that it has at the top. You don't need the mass cancels out, and carefully plug in the numbers and calculate. You're going to get 27.4 meter per second as the velocity with which it was launched. And here's the next one. A man lifts a 20 kilogram bucket of concrete from the ground up to the top of a 30 meter tall building. The bucket is initially at rest but is traveling at 4 meters per second when it reaches the top of the building. How much work was done? Again, this is a case of conservation of energy. So the work done is actually the gain in potential energy plus the gain in kinetic energy. Potential energy is mgh, and kinetic energy is 1/2 times m times v squared. Both, everything given, so you calculate that as 6040 joules, which is 6.04 kilojoules. Here we have a force acting on a particle that is a function of distance. So you can see that it's not a constant force. It depends on the distance. and it's constrained to move along the x-axis, so there are no y or z coordinates. And you have to find the work done. The basic definition of work is integral f dot dx between the limits, in this case 0 to 2. So that's how you do it. F is given, just take integral x is equal to 0 to 2 of fx dx, and integral of x squared is x cubed by 3. The 3 there is a constant. Here the integral of x is x squared by 2. 2 is a constant. And then you plug in the value, the upper limit in place of x, makes it 2 cubed in this case. And here, of course, the 2 and 2 cancel out, so it's 2 squared. So it's 2 cubed plus 2 squared, which gives you 12 joules. Right? That takes us to the last one. And in this case, a 6 kilogram block starts from rest and slides down a frictionless incline. When the block has slid a distance 2 meters, its speed is 3 meters per second. At what angle above the horizon, or above the horizontal, is the inclined plane tilted? Okay, here's the diagram. So the block starts from here and slides down. And D is given as 2 meters. So first we try to find H using energy conservation. It has potential energy at the top, but when it reaches the bottom, all of it changes to kinetic energy. So mgh is equal to 1/2 times mv squared. So you get H. And then from the triangle, you can see that sine theta is H by D. Use that and get sine theta and get theta. That's it. So that was one of the easier quizzes that you took. And thank you all for listening in and understanding. Wish you the best on the exam.